Hello everyone, my name is Rohit Kumar and today I will presenting a very important topic, network design for a corporate office. Imagine a large office where employees from different departments like HR, IT and sales are constantly using computers, printers and the internet. If the network is not designed properly, employee will face issues like slow internet, difficulty accessing files and even security breaches. In this presentation, I will show you how a well-designed network can solve these problems, ensuring efficiency, security, and scalability. Let's dive in. Now start with what is a corporate network. A corporate network connects employees, devices, and resources to ensure efficient operations. Its purpose is to enable secure communication, data sharing, and the internet access. Networks are the backbone of any organizations. Without a network, employees would have to transfer files using USB drives, wait for hours to download data, or even risk losing sensitive information. In this presentation, I will focus on choosing the right topology, assigning IP addresses efficiently, selecting proper cables and the transmission methods, ensuring security measures are in the place, managing bandwidth allocation for a smooth communication. Let me start by explaining the problems that arise with a poorly designed network. Now let's define the problem statement for a case study. In today's corporate environment, a reliable and efficient network is the critical for the smooth operations. Whether it's the IT team maintaining system, the sales team closing deals, or HR employees records, every department relies heavily on the network. The challenge is we need to design a network that meets the following requirements. First one is the reliability and the efficiency. The network must handle the workload of the multiple departments without downtime or lag. For instance, the IT department might need high-speed access of servers, while the sales team requires the reliable communications for the video conferencing. Second one is the scalability. As the business grows, the network should easily accommodate additional devices, users, and the new technologies. Third one is the robust and the security. Protecting sensitive data such as financial records and employee information is top priority. Measures like firewalls, VLANs are necessary to safeguard against cyber threats. Cost effectiveness. The design should balance quality and the budget, ensuring maximum value without overspending. Our objective is to create a network design that only meet technical demands but also align with the economic and the social need of the office. This includes enabling collaboration, supporting remote work, and promoting sustainability where possible. In summary, the problem is not just about connecting devices, it's about creating a strategic network that supports the entire organization operations effectively and securely. Now let's talk about network topology. Network topology refers to the layout of how devices or nodes are connected in a network. These nodes include devices like computers, servers, and printers. The links, which are the connection between the nodes, can be physical such as cables or logical such as wireless signals. Now let's talk about why topology is important. It determines how efficiently devices can communicate and exchange data. A well-planned topology ensures that data travels quickly and smoothly. The network can handle growth such as adding new devices. Downtime is minimized if a problem occurs. For example, imagine a city with roads connecting different areas. If the roads are well designed, traffic moves smoothly. But if the too few roads are poor connections, traffic jams occurs. Similarly, a poor design topology can slow down the network or cause disruptions. In summary, network topology is the blueprint of the network. It's the foundation that supports communication, scalability, and reliability. There are three types of topology: a star topology, bus topology, and ring topology. Let's start with a star topology. In a star topology, all devices are connected to a central hub or switch. This switch acts as the brain of the network, managing communication between devices. What are the benefits of a star topology? It's easy to troubleshoot. If one device fails, it does not affect others. Like when one student's computer in a lab stops working, the other communicate to function. It is reliable. Each device has its own connection, so data transfer is fast and uninterrupted. What can be the drawbacks of the star topology? If the central hub fails, the entire network stops working, like a school principal going on leave without assigning responsibilities. It can be expensive because you need more cables to connect all the devices to the hub. Let's take an example, a school computer lab, where every PC connects to a central server. This setup makes it is easy to manage and troubleshoot issues. We can also see in the diagram which is here, there is a central hub and the other system are connected to the central hub. If a particular system fails, it will continue to other system will continue the communication, but if the central hub will be fail, then the connection will be stopped immediately. Now talks about the bus topology. In this setup, all the devices are connected along a single backbone cable. Data travels through this cable and each device listens to find out if the data is for it. The advantage of the bus topology are, it is cost effective because it uses less cable. It is simple to set up for a small network like a office where a few devices are using the same internet. However, it has also some drawbacks. If the backbone cable breaks, the entire network stops working. Imagine a train where all the compartments are connected by a single chain. If the chain breaks, the train cannot move. It supports a limited number of devices. As more devices are added, the network slows down. A good example is a small office with a few devices sharing one internet line. While it works for a small setup, it is not ideal for the larger office. In the here diagram, we can see that there is one. Finally, let's look at ring topology. In a ring topology, devices are connected in a circular loop that travels in one direction around the ring, and each device check if the data is meant for it. The advantage of this setup includes no data collision because data flow in one direction, like a train running in one-way track. It can handle heavy traffic using a method called token passing, where only the devices holding the token can send data. But it has also some disadvantages. First one is, if one device or connection fails, it disrupts the entire network. Like if a train on a circular route breaks down, the whole schedule is affected. Troubleshooting is more challenging compared to a star or bus topologies. A real life example is a metro rail where train follow a circular route ensuring efficient traffic but flow in requiring all the stations to function properly. In our problem statement, we will choose the star topology because it is easy to implement and also troubleshooting is very easy. Let's move on to IP addressing. An IP address is a unique identifier assigned to each device in a network. Think of it as a digital equivalent of a house address. Just as your house address ensures a letter reaches you, not someone else, an IP address ensures that data sent over the internet reaches the right device. There are the two types of IP address, IPv4 and IPv6. IPv4 is the most common type with 32 bit. For example, 192.168.1.1 is an IPv4 address. However, it has a limited number of addresses. IPv6 is a newer version with 128 bits, allowing for a much larger number of the unique addresses, which is essential as more devices connect to the internet. The purpose of IP addressing is straightforward. It ensures communication between devices without IPs. Your computer your computer would not know where to send or receive data. For example, when you type a website address like www.google.com, your device converts it into the IP address to find and connect to Google's server. This process happens behind the scenes, but it is critical for the internet to work. Let's talk about the subnetting. Subnetting is the process of breaking a large network into smaller parts called subnets. This helps manage the network more efficiently. Think of it like dividing a large classroom into a smaller group to make discussion more organized and less chaotic. Now talk about why is subnetting useful. It reduces the congestion by dividing traffic into subnets. Device by device only communicate within their subnet segment unless needed. It enhances security since sensitive department like HR can be isolated from the general office traffic. Here is an example. Imagine a school with a single network. Subnetting can divide it into smaller groups, one for classroom, one for lab, and another for administration. Each group gets its own range of IP addresses, ensuring a smooth communication within the group while staying connected to the large network. For instance, the admin subnet might use address in the range 192.168.1.x. X can be vary, while the IT subnet uses 192.168.2.x. This separation keeps their activities organized and efficient. Subnetting makes large network easier to manage and ensure resources are used effectively. Now talk about the transmission media options. Transmission media is the pathway for the data transfer. Let's Compare the two main types, fiber optics and twisted pair. Fiber optics use light to transfer data. It is super fast and good for long distances. The twisted pair use copper wire for short distance communication. It is cheaper but slower. We can take example of train to understand chronology. Fiber optics are like express train. Delivery is fast but expensive and can be used for long distances. Twisted pair is like a local train. This is cheaper but slower and can be used for shorter distance. For our office, I suggest using fiber optics for the backbone and twisted pair for the internal connection within the rooms. This will help in maintaining speed and balancing the cost. Now let's talk about the protocols and their role in networking. Protocols are like a common language that devices use to communicate. Imagine you are speaking to someone from another country. If you don't have a shared language, you cannot communicate. Similarly, without protocols, device would not know how to exchange data. There are several important protocols that ensures network work smoothly. Let's explore a few. First one, TCP/IP, Transmission Control Protocol or Internet Protocol. TCP/IP is the foundation of the internet. It divides data into smaller packets, send them to the destination, and reassemble them in the correct order. It also ensures that the packets are reached their destination without errors. Now let's example. Think of a TCP/IP as a postal system. When you send a parcel, it's broken into smaller boxes, sent via various routes, and finally delivered to the recipient who resembles them. Second one is ARP, Address Resolution Protocol. ARP translates IP address to the MAC addresses. While IPs identify devices on the network, the actual data transfer happens using MAC address. Example, imagine your GPS knows the city, but need a street name to guide you the exact location. Similarly, ARP resolves the city as IP address to the street as MAC address. Third one is DNS, Domain Name System. DNS converts user-friendly domain names like www.google.com into IP addresses that computers can understand. Example, when you type www.google.com into your browser, DNS acts like a phone book, translating it into Google's IP address so your device can connect. Now talk about why are protocols important. They ensure data transfer is reliable, secure and efficient. Without them, networks would be chaotic and devices would not know how to interact. For instance, when you send an email, TCP/IP ensures it gets to the right person, DNS resolves the recipient's domain into an IP address, and ARP finds the correct MAC address to deliver the data. Protocols work together seamlessly to make modern networking possible, where you are streaming a video, sending a message, or browsing the web. Next, let's discuss security measure in networking. As we rely more on networks for personal, financial, and the business data, security becomes critical. It is essential to protect data from unauthorized access, theft, or damage. Think of network security as a combination of logs, guards, and the surveillance system that safeguard your house. Here are some key security measures used in networks. First one is firewall. Let's understand what the firewall is. A firewall is like a security guard at the entrance of a building. It monitors and controls all the traffic entering and leaving the network, blocking anything suspicious or unauthorized. Firewall can be hardware devices, software, or a combination of both. Example, imagine someone trying to enter a building without proper ID. The guard stops them. Similarly, firewall prevent hackers or malicious data from entering your network. Let's talk about VLANs, virtual LANs. VLANs are used to create isolated segment within a larger network. This separation enhances security base because even if one segment is compromised, the rest of the network remains safe. Example, in an office, VLAN can separate HR, finance, and IT department. If a breach occurs in one department, others are unaffected. Third one is encryption. Encryption ensures that the data is scrambled during transmission and can only be read by the intended recipients. It's like locking a letter in a box and giving the recipient's key. Even if someone intercepts the letter, they cannot read it without the key. Example, online banking uses encryption to secure your financial details while making a transaction. Third one is access control. Access controls define who can use which part of the network and what they can do. This prevents unauthorized user from accessing sensitive data or systems. For example, in an organization, only HR staff can access payroll data and only IT staff can modify network settings. These measures work together to create layer of security. For example, when you use online banking, a firewall protects the bank servers from external attacks. Your login data is encrypted, ensuring it's secure during the transmission. Access controls verify that only you can access your account. In conclusion, implementing robust security measures ensure a safe and the reliable network environment for personal and professional use. Let's discuss a bandwidth allocation in a corporate office. Bandwidth is the amount of data that can be transmitted across a network in a given time. A corporate office efficient bandwidth allocation ensures that all departments can perform their tasks without disruptions. What is bandwidth allocation? It is the process of dividing the available bandwidth among devices, applications, or departments to optimize network use. Think of it like allocating budget within a company. Each department gets a share based on its importance and workload. Why is it necessary in a corporate office? It prevents the congestion. Allocating bandwidth ensures that no single department or activity overload the network. It prioritizes the critical functions. Departments like IT or sales, which rely heavily on the network resources, get higher bandwidth to maintain efficiency. There are the two types which can be bandwidth allocated. First one is static allocation and second one is dynamic allocation. In a static allocation, bandwidth is divided into fixed portions for specific departments or tasks. In dynamic allocation, bandwidth adjusts based on the current demand. If sales needed more bandwidth for a client presentation, it can borrow from unused bandwidth elsewhere. Now take a real type example in a corporate office. Consider a medium-sized office with IT, sales, HR and the admin departments. 40% of the bandwidth is allocated to the IT department for several maintenance, database operations and running internal tools. It often handles critical systems that requires uninterrupted bandwidth. 30% of the bandwidth goes to the sales department and the similarly 20% to the admin and 10% of the bandwidth is left for the general browsing and the miscellaneous tasks shared across all the departments. A network cost depends on the hardware, cables and the security measures. Here is the breakdowns. As we are doing the cost analysis in this presentation, we are taking pre-assumptions. Let's talk. Hardware cost 5 lakh, cable cost 3 lakh, security cost 2 lakh. The total 10 lakhs, though it seems high, but this investment ensures long-term reliability and security. Let's look at some real-life example to understand why proper network design is crucial. Example 1. Take an example of e-commerce company faced several severe slowdowns during a peak sales. Customer could not place order leading to a revenue loss. This problem insufficient bandwidth. The solution was to increase bandwidth and use the load balancing which separate the traffic across the multiple servers. Now talk about the future scalability of the network. Our network design is not just built for today. It is also ready for the future. First, the design allows us to add new devices such as laptop, smartphone, or even IoT devices without disrupting the existing network. For example, if we add 20 new employees, we can connect their devices simply by adding another switch. Second, if a company opens a new office, we can securely connect both offices using a VPN. This ensures seamless communication between teams. Third, the company grow, the internet usage will also increase. We have planned for the bandwidth upgrades to handle higher traffic smoothly. Lastly, the design is adaptable for new technology. For example, as we move towards 5G or adopt IPv6 addressing, the network can easily integrate the advancements. This scalability ensures that the network can support the company's growth without needing a complete redesign. Let's now talk about the social impact of corporate network design. When you design a corporate network, its effect to go beyond just technology and efficiency. It has a profound impact on how people work, connect, and grow within the organization. Let's explore some key areas where networking design influences social aspects. First one is enhancing communication. Example, imagine an employee in India collaborating on a project within a colleague in the US. Using video conferencing, this connection would not be possible without a reliable corporate network. Second one is promoting accessibility. For example, during the pandemic, many companies relied on virtual private networks to allow employees to work from home. This not only kept business running but also ensured employee safety. Third one is facilitating knowledge sharing. Take example, a corporate network allow HR to organize company-wide training sessions on cybersecurity streamed to all employees. ensuring everyone stay updated and secure. Fourth one is encouraging sustainability. For example, by using the video conferencing for a meeting instead of flying employees to a central location, a company saves money and contributes to environmental sustainability. To conclude, let's revisit the main takeaways from our case study on corporate network. A well-planned network is much more than just interconnected devices. It is the system that supports the entire organization by ensuring efficiency, security, and reliability. Here what we have learned. First one is performance and scalability. Choosing the right topology, transmission media, and protocols ensure that the network can handle current need while being scalable for the future growth. Second one is security. Implementing firewalls, VLANs, and encryption protects data and ensures that the network is safe from threats. Third one is collaboration and accessibility. Bandwidth allocation and the IP addressing ensure that each department gets the resources they need to perform their role efficiently. Fourth one is social impact. Beyond technical functionality, a robust network fosters better communication, supports remote work, and contributes to sustainability by reducing travel and the physical resource usage. In the end, a corporate network is not just a technical asset, it is a strategic tool that drives productivity, facilitates innovations, and support organizational goals. As we move forward in an increasingly digital world, the importance of effective network design will only grow. A strong network is the backbone of the successful corporate office, enabling seamless operations and fostering growth. Thank you.